Okay, so this is my last video on trigonometric substitution, and this time I'd like to do an example where I have function squared minus constant, so I chose this one. And the appropriate identity, trig identity that we're going to use is the one which has function squared minus constant on one side, and that's secant squared minus 1 equals tangent squared, and here's the modified version. Now for us, on this problem, integral x dx over 36x to the 4 minus 25, okay, our a is 5. A squared is 25. So the appropriate identity is really 25 secant squared theta minus 25 equals 25 tangent squared of theta. So we're going to try to make the denominator look like this and then replace it with this. Okay, so what do we want in the end? We need 36x to the 4th to look like 25 secant squared theta. So that's what I want to have happen. Now what do I have to let x equal? Well, x to the 4th would need to be 25 over 36 secant squared theta. X squared would need to be 5 over 6 times secant theta. So this is where I'm going to stop with my substitution. I want x squared to be 5 over 6 times secant theta. Now this one's a little tricky. What am I going to do with what am I going to put in for the x up top? I'd rather not introduce a square root unless I absolutely have to. So what I'm going to do now is jump to solving for dx. So we're going to use the chain rule here. If I want to get the dx from x squared, we'll take the derivative of both sides using the chain rule. On the left, we're going to get 2x times dx over d theta is equal to 5 over 6 secant theta tangent theta. So it looks like x dx is 5 over 12 divided both sides by 2 secant theta tangent theta d theta. Okay, so I actually have an expression for x dx now. And the integral that we end up with becomes the integral of, let's see, on the top we have 5/12 secant theta tangent theta d theta. On the bottom we have, well, we got 25 secant squared theta minus 25. That was the whole point of the substitution. We forced it to have this form. And now we replace that with 25 tangent squared. So this becomes what? 25 tangent squared theta, and this is equal to 5 over 12 times 25. So what's 12 times 25? 300. 5 over 300 is 1 over 60. So we got 1 over 60. And we have secant theta divided by tangent theta d theta. And we'd like to integrate this. Now this isn't one of our classic integrals, so typically what one does in this case is break it down in terms of sine and cosine and simplify as much as possible. So let's see what we get. So we've got 1 over cosine divided by sine over cosine d theta. And that simplifies down to 1 over sine. So I've got 1 over 60 integral 1 over sine theta d theta. That's 1 over 60 integral cosecant theta d theta. And here's one of the ones that you were asked to memorize a while back. That's 1 over 60 natural log absolute value cosecant theta minus cotangent theta. Okay, now to finish this off, I need to get both of these trig functions back in terms of x. And if you remember your right angle trigonometry, what you can do is construct a reference triangle for theta and then come up with the expressions for these two trig functions. So let's go back to our original substitution equation, which was x squared equals 5 over 6 secant theta. We're going to use this to construct a triangle. How do we get the triangle? Well, we need to solve for our trig function. In this case, it's secant theta. It's going to be 6x squared over 5. Now, if you don't remember the ratio for secant, that's okay, because cosine, sine, and tangent, those are the ones you probably know. Let's go ahead and rewrite it in terms of cosine. It's the reciprocal, 5 over 6x squared. That's adjacent over hypotenuse. So now on our triangle, I'm going to make one where 5 is the adjacent side and 6x squared is the hypotenuse. So adjacent is here, that's 5, hypotenuse 6x squared. And if I use Pythagorean theorem to solve for the third, it's no coincidence, but this is going to end up involving the expression that made us do the substitution to begin with. This is going to be the square root of 36x to the fourth minus 25. Now, I need both cosecant and cotangent. So, what is cosecant? Cosecant is the reciprocal of the sine function. So I can get that directly off of this, cosecant of theta. Well, the sine is opposite over hypotenuse, so cosecant is going to be the reciprocal, hypotenuse over opposite. That's 6x squared over the square root, 36x to the fourth minus 25. And I also need cotangent. You probably remember tangent. Tangent of theta is opposite over adjacent. So tangent of theta would be this over that. Cotangent of theta is going to be 5 over this square root. So 5 over the square root, 36x to the fourth minus 25. And now we just go ahead and substitute that in here, paste it into our final answer, and we're good to go.